countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by e-Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening and hi to all teachers, parents and the wonderful student. Welcome to Pusat Tuisyen AYU YouTuber, a joint venture with the e-Didik Malaysia and Kelab Guru Malaysia with the hashtag of bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of the Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. So how's everyone? My prayer that everyone in the best of health and ready to proceed with our today's class. So before we start, let me introduce myself first. My name is Nun binti Muhammad Nur. You can call me Madam Nun. I am your moderator for today's class. I am a lecturer at the College Matrikulasi Negeri Sembilan, Kuala Pilah. So together with us today, we have teacher Hafsah Ayu as our host controller from SMK Sultan Sulaiman, Kuala Terengganu, and teacher Suryati from SMK Sri Serdang, Selangor. All of us here are to ensure that today's class running smoothly. So, and the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua, Kajang, Selangor. So, let us give a warm welcome to our presenter. For the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel and all of you can visit channel teacher Suryati, teacher Hafsah Ayu, and also my channel to get a lot of physics learning material, and not forgetting to subscribe their channel too. As usual, the lesson will be approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. Remember that you can only use e-Didik email. For credit claim, you need to collect the 1 letter and 4-digit code, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind students to use appropriate language and use appropriate profile picture if you wish to post comment in the chat box. I am pretty sure that all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. So stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answer. Before I give Madam Rosmaya to present, I will announce the first code for credit claim. Okay, so the digit is A6. A6. Okay, so you make sure that you write down somewhere, and after this, I will give you another digit. Okay, so without further ado, let's welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya.
Okay. Okay, so hi everyone. I am Madam Rosmaya. Okay, so before we start, I'm going to introduce the Academy YouTuber Pre-U teams. Okay, so we have here our team, okay, physics team, lead by me. I'm Madam Rosmaya from SMJK Yuhua, Kajang. I'm a Form 6 teacher. Okay, together with us, all of us are physics teacher. Okay, we have teacher Su here, Okay, teacher Hafsayu and teacher Non, our moderator. So not here with us is teacher Suhaya. Okay, so the next team, we have maths team lead by teacher Im. Okay, we also have biology team, okay, lead by Cikgu Faiza. We have chemistry team lead by Cikgu Shahnon. And perakaunan dan ekonomi team lead by Madam Fizi. Okay, so besides that, we have other subject also like the STPM subject MURID. We have pengajian pengajian perniagaan, and a lot of the pre-U subject. Okay, so now back to what we are going to discuss today. So what are we going to discuss today? So we are going to solve problems I gave to you all already in the description below here, okay, below the YouTube here. So our objective is students will be able to solve problems on Newton's laws of motion by applying appropriate problem solving techniques. Okay, so before we start, we recall what we have discussed, the three laws, the three Newton's laws. So there are three Newton's laws. The first one is relating to the here an object. The Newton's first law of motion, okay, state that an object at rest remains at rest, and an object in motion continues in motion with a constant velocity. Okay, there is constant speed in a straight line unless it experiences a net external force. So we can summarize it as object keeps on doing what they are doing. But in the exam, don't write like this. You must write in a proper statement like this. Okay, so you've learned in the secondary school already, right? So the two example given, the famous example here. So in this animation, without being properly secured, the ladder continues moving forward even though the truck stopped here. Another example, the man here without a seatbelt, the man continues moving forward even though the car stops. So this one is Newton's first law. So the tendency to resist change in motion is called inertia. Okay, so this is what we discussed before. We recall what the statement of Newton's laws. Okay, the second law we are going to use later in our discussion is Newton's second law. So which state the rate of change of momentum of a body is directly proportional to the resultant force acting on it, and is in the same direction as the resultant force. So the direction of the resultant force usually in the direction of the A. Okay, so we refer to the direction of A because we are going to write down the sign or positive, whether it's positive or negative for the force we are going to substitute later in our solving problems. Okay, another word we can say that the Newton's second law, okay, more mass means more force needed to accelerate. But actually you are already, but from the statement here, actually we can write like this, okay. So this is the net force or resultant force. Some books use resultant force, some books use net force. So the resultant force is equals to dp by dt. This is the rate of change of momentum. So momentum P is equals to mass times velocity. So when we substitute into here, so we use differentiation rule. So what we get? We get m dv by dt plus v dm by dt. So we use differentiation rule. Okay, so we use differentiation rule. So we get this v dm by dt plus m dv by dt. So you must upgrade yourself because you are pre-U student already, not the secondary school. So what you've learned before in Form 4, Form 5 is more on this case actually. So we from here we can divide into 4 cases, okay, for your level, the matrix and STPM level. So for the first case, if we the case where mass constant, okay, mass constant and the velocity changes over time. So from this equation, if the mass constant, this term will be equals to 0, right? Because no change in mass constant. So that means this terms is equals to 0. So what we get here is F equals to M dV by dt. Yes, the product rule. Muhammad Shafiq. From this one comes from the ADMAT's differentiation rule. So we use the rule, so we get this. So in the first case where mass constant, so we have F equals to M dV by dt. Okay, so dV by dt is equals to A. So that is why we get the second law. One of the branch of the second law is F equals to MA. Okay, the formula we derive. Okay, so another, this is for the case for M constant. If we increase the force, so what happens? Acceleration also will increase. Okay, so now for the next case, where acceleration constant. Okay, from this equation F equals to ma, so now acceleration is constant. So what happened? F and M change. So how they change? So if we increase the mass, so what happened? We need a larger force. Okay, greater force for the same acceleration. Okay, so this is for the second case. Okay, then for the third case, where the force is constant. Okay, if the force is constant, so what is the relationship between M and A? M is mass, A is acceleration. So if we increase the mass, so what happens? The acceleration will decrease. So acceleration will decrease when a larger mass in the cart is pushed with a constant force. So besides these three cases, we are also going to solve one question I give to you all in the worksheet given before already. Okay, so in the fourth case where velocity constant. So when velocity constant from this equation, okay, what happened? So dv by dt will equals to 0 because velocity constant, right? So there is no change in velocity. So the equations become F equals to V dm by dt. So dm by dt is the rate of change of mass. Okay, so the example given for this situation is in the rocket launch. So in the rocket launch, okay, so the greater the rate of fuel consumption means that the rate of change of mass, the burn rate actually. So the greater the upward thrust of the rocket. So another example is in the conveyor belt here, where sand from a stationary hopper falls on the moving conveyor belt. So the conveyor belt is supported by the frictionless rollers. So it moves at constant speed. So the V here, the speed constant. And the mass here changes with time. So dm by dt. Okay. So this is the two example given for the fourth case. Okay, so now after we recall to what we discussed before, okay, in the lesson given by your teacher, or for the form 4, form 5 also actually, recall to what we have discussed. So now we go to the first question. Oh, we forgot. Okay, got one more. We haven't discussed. We haven't recalled this one. Newton's third law of motion. Okay, so for the Newton's third law of motion, so if two objects interact, the force exerted on object 1 by object 2 is equal in magnitude, but opposite in direction to the force exerted on object 2 by object 1. So as a layman, usually we think like this: when you push an object, so it pushes back. So forces always come in pair. So when the object interact, the forces are equal but opposite in direction. Okay. So this is the example, okay, famous example given by your teacher. So during class, okay, so when you jump off a small rowing boat into the water, like the man here, you will push yourself forward towards the water. So the same force you use to push forward will make the boat move backward. So another example is when you dive off a diving board. So you push down on the springboard, then the board springs back and forces you into the air. Okay, so okay, done for all the 3 Newton's laws of motion. Okay, so before we start the our discussion on the worksheet questions in the worksheets given, So I want to give you all tips to solve Newton laws of motion. Okay. So the first tip, okay, you must read the problem carefully. Okay, so read more than one time. Maybe you will leave one or two. Cannot understand. You can read it twice. So make sure you understand the question. Understand the question. Really understand the question. So better read twice or more. Then the second tips is draw a sketch. Draw a sketch, then a free body diagram. Okay, so sketch really help you to get the idea how the situation given in the question is. So then you draw all forces acting on it in plane. Okay, so for the fourth tips is list or label the known and unknown quantities. So you label everything, then you can get the idea, the relationships between the variables or the unknown or the known quantities. Okay, then the fifth tip, then you can start solve the problems. But must be careful, keep track of dimensions. So if the dimensions, make sure all the dimension used is the same. Okay. Then the sixth tips is make sure your answer is reasonable. Sometimes when we do calculation, we make careless mistake, right? So this one might help you to when your answer you find that it's not reasonable, then you can recheck your where you go wrong. Okay. Okay, so now we are going to start discuss the first question. Okay. So the first question, we read together first. Boxes P and Q, okay, we have two boxes here, P and Q, are in contact on a horizontal frictionless surface. Okay, so box P has a mass of 20 kilogram and box Q has a mass of 5 kilogram. So a horizontal force of 250 Newton is exerted on box P. So what is the magnitude of the force that box Q exerts on box P? Okay, so box Q exerts on box P. Okay, so the first step, determine where the direction of the motion is or acceleration. So when the force give at this side, okay, 250 Newton at this side, so that means they move together to the right, to the right. So in this direction. So why we need to write this direction? Because later all the forces need to put sign, positive or negative. So the sign will refer to this direction. So if same direction as the acceleration, so that means the force is positive. Okay. So that's why it's very important to determine where the direction of acceleration is or where the direction of the motion of the object is. So this means to the right. Okay, so now next is to determine all the forces that act on this object. Okay, besides this force, 250 Newton, we have also action-reaction force. P exert on the force by P exert on Q and Q exert on P. So this action-reaction force is the same from Newton's third law, right? So they are the same. So we just name it as F. No need to write F1 or F2 because they are the same. Or you want to name it as FP or FQ. No need because they are the same. So just write F. Okay, so the weight of these two objects is not involved. Okay, because it's perpendicular to this forces horizontal to the motion. So we don't no need to write lah. The force. The force of the weight and also reaction. Why? Because the object doesn't fly. The object doesn't fly, or the table or the ground here doesn't collapse. So they maintain motion in a horizontal motion. So that means reaction force and the weight is equals. They are balanced. So no need to involve in our motion here. Okay, so now start to use the Newton's law. This is also Newton's law, action reaction force just now. So another Newton's law is from F equals to ma. Okay, to use F equals to ma, we sketch or we draw separate body diagram, or another word, a free body diagram. So free body diagrams means we refer to the body individually. Like here I draw separately, so that you don't get confused. Actually, no need to draw separately also. But I just draw separately to see what are the forces act on the P, and the force that act on Q. So the force act on P is this 250 Newton and the reaction force Q on P. So this is what we are going to find actually, this F. Look at back the question. So force that box X exert on box P, right? So this F lah. This F is force that box Q exerts on box P. Okay. So then for the box Q, we have only one force act on it, which is this one, this F also, but to the left direction. Okay, so very good. Those who have answered the question, and because I give earlier already, right? So very good. You can write there in the chat box. Okay, so we have here Ninely. How to pronounce your name? Okay, so you got 50 Newton. So the rest of you, if you got the answer already, so you can write there in the chat box. Okay. Okay, now continue. Okay, now we form two equations from the two bodies, box, actually box P and box Q. So from the first box, okay, we have 250, the same direction as the A, so we consider it as positive. And the F is opposite direction, so minus or negative, plus negative F or minus F equals to. So they are moving, okay, to the right. So this, the MA is M by P, okay, MP here, substituting MP into the equation here, and then A, this A. So for the, this is first equation. For the second equation, for this box, so we have F, only F, only F, and same direction as the A, so it's positive. F equals to MQA, because box Q, right? So MQA. So now we have two equations, and we solve using simultaneous equation. Okay, so F and A is the same. So we can use simultaneous equation and substituting the values here. Okay, all values into the both equation. Okay, then we can solve simultaneous equation. So you can use substitution method, you can use simultaneous equation method, or ratio method, is up to you. Okay, there are many ways to do simultaneous, to solve the simultaneous equation here. And what's the questions one just now? F, right? Okay, so you substitute A into here, so you get F 50 Newton. Okay, correct. So Ninely got correct answer. Okay, hopefully the rest of you also get the same answer. If got problem, you can ask there in the chat box there. Okay, so the moderator can help me to read all the chatting there. Okay, so now we go to question 2. So if
Madam Rosmaya, before we go to the question 2, can I share the second digit code?
Okay.
Yeah. So okay, student, the second digit code, our second digit code today for our class is 0. Okay. Please write down somewhere. Make sure that you remember the first code just announced earlier. This is the second code, which is 0. Okay. So, Madam Rosmaya, you can continue. Thank you.
Okay, so thank you, Teacher Non. Okay, so now we go to the next question, question 2. Okay, for question 2, we have 2 blocks here, but this time they are attached by a string. So those who get the answer already can write there in the chat box. Okay, now we have 2 object here. One is mass 3m, the other one is m, attached by a string. Okay, so the what you call this, the surface here is frictionless, so that means it is understood that no friction force are involved. Okay, only this F, and we have another force which is tension in the string. So you determine all the forces that act on these 2 objects. Okay, so before that, again, we need to determine direction of motion first, or acceleration is this way, right? Because the F here pull these 2 objects with a string. So that means direction is this way. So this is direction of A. Then we have tension in the string. So tension in the string here is a action reaction force, okay, by this M to this 3M, okay, 3ms, and the 3ms by the M. Okay, so that's mean they are action reaction force which has the same value because they are in the same string. Okay, so when you pull this M, okay, what happened? The string here pull because of the force here, so it pull also the 3M. Right? So there's a tension in here. Then after it is pulled, so because of the weight of this what you call because of this block, 3M block, so therefore it has also the tension because of this block. So there's a tension here is a action reaction force by each of the box or what blocks on the small blocks and the small block on the big blocks. Okay, sorry, twisted tongue. Okay, so now F equals to MA from Newton's second law. Again, we use Newton's second law here. F equals to MA. Okay, so we can forget about the we use free body diagram. Okay, free body diagram. So that's mean we can ignore the first the 3M block. So refer just to the M block here. So that's mean the force act on this block is F minus T, because F is positive, is to the right because same direction as A, and T is opposite. So minus T. Okay, so F minus T equals to MA. So the M here is M of the block here. Okay. Then we do the same for the second block. So for the second block, okay, we can ignore the M block. So just refer to the 3M block. This is what is meant by free body diagram. Okay, so the force that act on this block is T. This T. Okay. So T, same direction as A, so that means T is positive, so equals to MA, M is 3M. Okay, then the A is the same for both of them, move together with A, right? So A is the same. Okay, so now we have two equations, right? We have two equations, so we can solve using simultaneous equation again. Okay, so to use the simultaneous equation, so you can substitute the T into here, because they have this is action reaction force, the T here substitute into the equation, and we solve for T because the question's one T, right? Okay, the question's one tension in the rope. So you solve, you get 3F per 4. So anyone get the same answer can write there in the chat box. Okay, so done for question 2. So if you have any problems, also you can write there in the chat box. Hopefully I'm not explaining too fast. You can understand. But if you miss somewhere also, you can always refer back to this video. Okay, I will upload this video in the YouTube for you all. Okay, so okay, now can we continue? Okay, so question 3. Okay, we have two masses here, 8 kilogram and 12 kilogram are connected at the two ends of a light inextensible string, okay, that goes over a frictionless pulley. So we don't care about the friction. So find the acceleration of the masses, okay, and the tension in the string where the masses are released. Okay, again, first step, where the direction of motion is, so means the direction of acceleration. So logically, this is 8 kilogram, this is 12 kilogram. So that's mean direction of acceleration is downward by this side, 12 kilogram. So it pull this 8 kilogram because this one larger mass, right? So the direction of motion is here, downward. And whereas the 8 kilogram, we move upward. Okay, so it go this way. Okay, then we determine all the forces that act on the object. Okay, so we have tension in the string, because we have string, so we have tension in the string. So the direction of the tension here is upward. For 8 kilogram also upward, because the tension here because of the weight downward, cannot be the same direction, because we have weight here downward. So tension must be upward. Same goes on 8 kilogram. And because of the weight of 8 kilogram, so the tension in the string on the right side also T. And they have same value. Why same value? Because they are from the same string. Okay, they are from the same string. Okay. Then the another force is the weight. So let's name this as M2G and this one is M1G. Okay, weight is equals to mg, right? Okay, so now using the F equals to ma, so we can forget about the 8 kilogram for a while. What is this method called? We call this method as a free body diagram. Okay, free body diagram. So just refer to the 12 kilogram. So the forces act on it is T and M2G. So that means M2G is positive. Why it's positive? As I said just now, always refer to the direction of A as a reference for the sign positive or negative. So A is downward, so that means M2G is positive. So T is upward, so it's minus T. Okay. So equals to M2A because the mass of the object here is 12 kilogram. This M2 is 12 kilogram. Okay, so now for the second equation comes from 8 kilogram. So we have T minus mg. This time T is positive because direction of acceleration is upward. Okay, the 8 kilogram move upward. So T now positive, not like the 12 kilogram just now T is negative. Do you realize or not? The difference. So for the 8 kilogram, the T is positive and the M1G is negative, because opposite direction of the motion. Okay, then MA, so you substitute M8 kilogram into here. Okay, so you use simultaneous equation to solve for what the question asks. The question asks for acceleration. Okay, so you substitute the values. There are two methods actually. You can substitute the values given earlier, or you can write in the variables. Substitute the variables. Then finally you substitute also can. So in this case, I substitute first the values into here. Okay, the 8 kilogram here. Okay, now T into the second equation. This T into the second equation. Okay, then solve for A. So the A is 2 meter per second per second. Okay, so do you realize that before we come to the final answer, okay, make sure you don't round off too early. Okay, don't round off too early. So that's why I use the large the means 117.72. You want to substitute 117, 118 also can, as long as you don't round off too early. To here given 8 kilogram and 12 kilogram is about 1 and 2 significant features. Okay, so the final answer is 2 meter per second per second. Okay, that's for question A. Answer for question A. Okay, next for B, tension in the string. So you substitute A into the either one, equation 1 or equation 2. In this case, I substitute into equation 1. So you get 94 Newton. Okay, so that's question 3. I think we can take a rest now, Teacher Nun, Madam Nun.
Okay, we have a break. So we will watch the advertisement. After that, I will share the third digit code. Okay? Let's watch
Berita
the
baik
advertisement.
untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so the third digit code, okay, please pay attention. Our third digit code is Wait, our third digit code is 3. Number 3. Okay? So make sure that you write down somewhere. Now we will proceed with Madam Rosmaya presentation. Thank you.
Okay, thank you, Madam Nun. Okay, so we continue with question 4. Question 4. Okay, for question 4, we have two meshes here, M1 and M2 are connected to the two ends by a string. Okay, also by a string here, passing over a frictionless pulley. Okay, again a frictionless pulley, so no friction involved. And M2 is placed on a smooth inclined plane. So what can be understood here by smooth inclined plane? Also no friction involved. So if it is not smooth, you must involve the friction. Okay, so that now we don't involve friction. Then find the acceleration of the masses and the tension in the string if the M1 here is 20.5 kilogram and M2 is 10.5 kilogram. So the angle here is 45 degrees. Okay. So anyone there with the answer, you can write there in the chat box. So if you don't afraid to make mistake, it's okay. So nobody write there yet, Madam Nun. Okay, but it's okay. We continue. Now we label here because if not we get confused, right? So we label here. M2 is 10.5 kilogram and M1 is 20.5 kilogram. So which one is greater in mass? So 20.5 greater in mass. So therefore, where's the motion? The motion of the object will be, for M1 will be downward. Okay, for M2
Yes.
will be upward. So always refer to the motion first. Always refer to the motion of the object. If this one is larger, so if the mass 2 is larger, so the direction of acceleration will be different. Okay, so that's why we need to determine the direction first. Why we need to determine the direction of acceleration? Because for the sign positive or negative, we always refer to the direction of motion. Okay, now label all the forces. Okay, determine all the forces. So for M1 we have weight M1G, and then for M2 is M2G. Okay, so the tension in the string, tension opposite direction but same magnitude. Why? Because they are
Same
on the
string.
same string. Okay, so now this M2G, we need to resolve the two component because the Cartesian we choose now is no longer vertical for y-axis and x-axis horizontal. So the y-axis will be perpendicular to the plane here, whereas the x-axis is along the inclined plane. So therefore, the component of M2G will be M2G sine theta and M2G sine theta, where theta here is 45 degrees. So this one you use similar triangle to prove the angle. These two angle is the same. Okay, you've learned this in maths already, right? Okay, so when you are secondary, so how we get these two angles is the same. Okay, we use similar triangle rules. Okay,
At the
so
Y, Madam Rosmaya, at the Y supposed to be M2G cos theta, right? Am I
where
right? Y
Huh?
component for the weight.
for which one? Which one? And this one.
Y component.
This one should be
M2G
cos.
cos,
Cos
yes.
theta. So typing error here. Okay.
Yes.
So got typing error here. So this one should supposed to be mg2 cos theta. Okay, and this one will be m2g sin theta. Okay. Thank you, Madam. Madam Nom, because typing error here. Okay. So now. This is because copy paste lah ni copy paste. That's why we have
Yes.
typing error here. Okay, so now back to the F equals to MA. So we can forget for a while about the M1. So just refer to the M2 because we use free body diagram method. Okay, free body diagram method. So we just refer to the M2. So now direction of acceleration is this way. So that means the T is positive. T is positive. Okay, along the x-axis, horizontal means along the inclined plane as the x-axis. So T is positive because same direction as A, And then we have M2G sine theta, opposite of A. So that's why minus. Okay, that's why we put minus. So M2G sine theta is minus. So T minus M2G sine theta equals to MA. So the M here is M2 and the A is this acceleration. Okay, then the R and the mg cos theta, this one is mg cos theta, they are balanced because the M2 here doesn't fly, or the inclined plane here doesn't collapse. So R is equals to mg2 cos theta. Okay, so we don't use this unless if friction involved. So now friction not involved, so we are not going to use these two relationship. R equals to mg to cos theta. I repeat again, here is cos theta. Okay, so this is equation 1, and then the second equation refer to this M1. So tension is upward. Okay, this time tension is negative because the acceleration is downward. Okay, the acceleration is downward. And M1G is positive. So M1G minus T equals to M1A. So this is second equation. Okay, not? If got problem, can write there in the chat box. Looks like they are okay. Okay. So the next step is simultaneous equation. Okay, you use simultaneous equation to solve for whatever asked by the question. You can solve for A and you can solve for T. The question asks for both. Okay, so you can solve for both. So T equals to M2, T is M2A plus M2G sine theta. Then you substitute into here. It's up to you actually to use whatever simultaneous equation method. But now I'm using substitution method. So substitute T into equation 2. So you got this. Okay. So now expand the bracket and bring to one side for those for terms which has A. So M1A plus M2A. So we can factor out A because we are going to determine A, acceleration. So the rest, M1 plus M2 here, put to the right side here. Just exchange the position. And this time, I arrange first, then only finally I substitute the values. Okay, I'm not using the first previous method. We substitute first the values. This time, I substitute later after combine the equation. Okay, so now M1 is 20.5, G is 9.81 minus M2 is 10.5, G again 9.81, sine 45, and M1 plus M2, 20.5 plus 10.5, and the answer is 4.1 meter per second per second. Okay, so done for acceleration and for tension. Can choose equation 1 or equation 2, is up to you. Let's say we choose equation 2 here, M1G minus T equals to M1A. So again, we substitute M1, 20.5, G 9.81 minus M1, 10.5, A is 4 point. Do you realize that for A, I didn't round off too early for the tension. So I substitute 4.138 here, not for this 4.1 so don't round off too early. At least you write one step number of significant figure higher. Okay, so that's why I substitute here 4.138, and the final answer is 153 Newton. Okay, for tension. Okay or not? So be careful with the number of significant figures at the final answer. Okay, so we go to the next question. Okay, question 5. Okay, so the window washer. Okay, here is the window washer of mass 62 kilogram. Pulls herself upward using the bucket pulley system. Okay, as shown in the diagram. So given the mass of the bucket is 10 kilogram. So how hard must she pull downward to raise herself slowly at constant speed? And then next question B, if she increases this force by 15%, so what will her acceleration be? Okay, so we do question A first. Okay, for question A, we what you call this direction. Okay, determine the direction of acceleration first. So imagine this window washer pull the rope. So what happened? So this rope on the right side will go downward, and the window washer will go upward. Okay, this is where the motion is. Okay, so you label the motion. You label the motion first because we are going to use the sign positive and negative by referring to the motion. Okay, so next we label all the forces that act on the system here. Okay, so the window washer pull this with with force F. Let's say generally we put F because we are going to find this F actually. The question said, how hard must she pull downward? So that means this F. How hard she will pull. Okay, so we are going to determine this F. That is what the questions A wants. This F. Okay, then this F followed by the what you call this window washer move up by this force also. This F pull down here, and because of this force, the window washer move up. They are the same because pull this rope and the other rope attach right. They are actually one rope. So this F is equal to this F. Okay, then another force is mg. Okay, weight of the both the window washer and the bucket. Okay. Okay, I can
Wow,
see.
dah ada.
Okay, very
Dah
good.
lock chong.
Okay, so let's check later the answer. Okay, now another force is tension. As usual, if got a string, so they must have tension in the string. So tension in the string T here, because you pull F, so there must be tension in the string. Okay, so tension in the string for this side. So we have another side also tension in the string. Okay, so opposite direction. Because tension in the string here, opposite means on this side is opposite direction because of the weight here. Okay, now we use F equals to MA. Okay, first we refer to this one first. Pulling force by the window washer the hand here. Pull force. So F equals F minus T because direction downward, right? On the right side. So direction A is downward. So F is positive, T is negative. So F minus T equals to Y0 because constant speed. So means acceleration 0. So equals to 0. Okay, this is first equation. Okay, then second equation, the other side. The other side of the rope. So we have here the F, this F upward, then plus T because same direction as A, move up. So F plus T minus mg. Okay, mg equals to 0. So why? Because constant speed. Okay, so now we have two equations and we can solve using simultaneous equation. Okay. So you substitute this F equals to T, okay. So you substitute into here. Then F plus F is 2F equals to mg. So F equals to M. M is 72 because total mass of the bucket and the mass of the window washer itself. So 72. Okay, 62 plus 10. Okay, and G is 9.81 divided by 2. So we get 350 Newton. Okay, 350 Newton. Okay, chong kalok. Okay. So next is question B. So the window washer must pull with this force 350 Newton for her to rise in constant to move in constant speed. Okay. Never mind, good try. And check where you went wrong. Okay, check when you went wrong. Okay, so next question B. Okay, this time the window washer pull with 50%, increase by 50%. So from 350, so plus another 15% from this one. So we need to calculate first. Okay, so the same forces. Okay, but this time acceleration is not zero. Acceleration is not zero, because not constant speed anymore. Okay, constant speed is if it use 350 Newton. So again here, F minus T equals to, and okay, for this side, so F minus T equals to 0, because this is actually action reaction. It has acceleration here, MA, but F equals to T. T comes from this F. Okay, the tension here comes from the F. It's pulling with F. So it depends on the T here. Okay, so now the right side, F plus T minus mg. So it accelerate the, what you call this, window washer upward with this acceleration. Okay, so the force gives the tension in the string. So you substitute into the equation here, F plus F minus mg. Okay, actually got MA. Typing mistake lah here. MA. Got MA. So never mind lah. I don't want to redo this actually. So F minus T equals to MA here. Typing error actually. So you substitute this into here. Okay, then you solve for A. So actually what I'm doing here is wrong because got typing error here, but it's okay. So you just solve for simultaneous equation, okay, using the same method, but this time you need to increase the force increase by 15%. So that's mean no longer 350 to substitute into here. Okay, but never mind, we continue lah. So the acceleration is 2F minus mg, but remember again, this one actually supposed to be what? T plus ma. T plus ma. Okay, then for the 350, you add the 15%. Okay, you add this 15% plus the 350, 3.16. Okay, so the value here, you substitute into here. Okay, for the force, and you get the answer. Okay, so the answer here is wrong. Okay, I repeat again, the answer here is wrong. Why? Because here I didn't put it as MA. Okay, but you all do using simultaneous equation. So you use here as MA. So that means you substitute MA plus T into here. Okay, not? Okay, so don't refer to this answer. And for the done already actually. We get the question, answer A already. Okay, so we go to the next question, question 6. Hopefully you understand. This one is typing error equals to MA. If you understand what the mistake here, you can write there in the chat box. At least I know something that you listen to what there is a mistake here. Okay. Okay. Okay, now we go to question 6. Okay, question 6. Okay, question 6. Okay, a 2 kilogram hanging block pulls a 3 kilogram block along a smooth table. Smooth table, so that means no friction involved. Okay, no friction involved. So calculate the acceleration of the system and the tension on the string. Oh, sorry, student. Go back to the question just now. I remember something. Okay, so here is correct 0. Okay, why? Because there is no object here, M. So it's 0. So it's not necessary not just because of constant speed, because no object here. So the answer here is correct. I repeat again. Okay, I repeat again. The answer here is correct, 1.5 meter per second. Okay, because the M here is 0. No M, no weight here, right? Okay, no weight here. So this one is correct. Okay. Okay, so hopefully you understand. If you can write there in the chat box. So this one is correct. I repeat again, the answer here is correct. 1.5 meter per second per second. Why? Because the first equation here equals to MA, so no weight involved here. MG, no M. So no mass here involved. So that's mean is 0. So F equals to T. So correct, So the answer is correct. Okay, now we go to the question 6. Okay. Question 6. A 2.0 kilogram hanging block pulls a 3.0 kilogram block along a smooth table, so no frictional force. So we are going to calculate the acceleration. Okay, so first step, look at the direction of acceleration. So motion. So it's downward because this one pull this. Okay, this one going down, so it pull this 3 kilogram block. Even though this is only 2 kilogram, but still managed to pull because downward direction here. Because this is smooth, no other friction, no friction involved. So this one is smooth, so it managed to pull the 3 kilogram. Okay, horizontally. And this one is vertically downward. Okay, so direction of this 3 kilogram is to the right horizontally. Okay, now the R equals to M2G because the object here again doesn't fly and the table doesn't collapse, doesn't break, right? So R equals to M2G, but we are not going to use this. So tension in the string again here, T. So from F equals to MA. So for this object, M1G is same direction as A, so positive, minus T. T is upward, okay, minus T equals to M1A. And this is equation 1. Okay, then equation 2 comes from this block. The T, okay, T equals to M2A, because MA here, right? So M is M2A, but the T only involved because R equals to M2G, not involved in the direction of A. It's perpendicular. So T equals to M2A, just for equation 2. Okay. Yes, Wolfgang said, why for question 1 and 2, we don't consider MG, but for this question, we do. We don't consider also for this question because R and MG, they are the same. R and M2G, they are the same. R equals to M2G. If you want to write here also can, but the question's only one tension and acceleration. So it doesn't involve unless if got friction. Okay, if got friction, then we need to use the R here equals to M2G. But now because the question states smooth, so we're not using. Okay, R equals to M2G. But actually there's a forces here, R and M2G. But refer to the question only asks for acceleration and tension. So these two equations enough already for us to find what the question wants. Okay, so now we use simultaneous equation. We substitute this into here and factor out A, M1 plus M2, and we solve for A. Then substitute the values into the equation. So we get acceleration is 3.9 meter per second. And for the tension, you can substitute into here and we get T tension equals to 11.8 Newton. Okay. Okay, now we still can discuss one more question. Okay, one or two question, right? Okay, one or two more question. So I go faster. Okay, 2 masses are hanging from the ceiling here. Okay, so we have 3 kilogram and 2 kilogram. So we have tension in the string here, T2, but the tension at the upper rope, a rope or string, wire. So the tension in the upper wire is not the same as the below, because this is vertically. Okay, vertically. So tension not the same. So the upper wire will be T1, the second wire T2. Why not the same? Because T1 depends on these 3 kilogram and 2 kilogram. Whereas the T2 tension in the second bottom wire is because of the weight of this 2 kilogram. Okay, then the weight, first one M1G, the second one M2G. Okay, so now we solve for using F equals to MA. So use free body diagram. Okay, for the first diagram, ignore the second diagram below diagram here. The masses, the mass below. So just refer to the mass on top. So if we have T1 minus T1. Okay, T1 minus T2 plus M1G. So this one actually is constant. Is equals to 0. So it balance. T1 equals to M1G plus T2 also can. Okay. Hanging from the ceiling. So that means MA here is 0. Okay. So equation 1. So for equation 2 also not moving. No A. So that means T2 equals to M2G. Okay, T2 equals to M2G. Or you can write like this, T2 minus M2G equals to 0. Okay, now you solve for simultaneous equation. So you get T2, 20 Newton and T1, 49 Newton. So do you realize that I didn't substitute 20 here? Because before come to the final answer, don't put the round off. Don't round off too early. In other words, don't round off too early. Okay, so I think I'm going to discuss one more question. I hope we have still got time. Okay, for the question 8, this time they move. Just now is 0. Just now no acceleration or no motion. This one got motion which is upward. Okay, upward A. So we do the same method. 2 different tension. Top one and the bottom here. But this time, the got acceleration. So M1G, M2G is the same. So the first equation, follow the direction of A, T1 positive, minus T2 minus M1G equals to M1A. So do you realize that we have M1A here, not 0, not equals to 0, because it moved, accelerate with acceleration A. And the bottom mass, T2 minus M2G equals to M2A because this mass. Okay, so now using simultaneous equation, so you substitute, you get T2 47 Newton and the T1 is 71 Newton. Okay, so for the question 9 to 12, I will make a video for you all to check your answer. Okay, so I give back the class, the discussion today to Madam Noon.
Wow, really fantastic, right? You are very, very lucky. You will get another solution in Madam Rosmaya video. Okay, please watch later, yeah? So, Alhamdulillah, we have reached the end of today's session. So, congratulations, those who can follow our session from the beginning till the end. So, before we end our session for today, I will announce the 4 or the last digit code for credit claim. So, the digit is 9. Okay, number 9. All right. So you can combine the numbers. Okay. All right. So all of you, please stop posting your comment for a while. And if you haven't clicked the subscribe button, please do so. Make sure that it turns to gray color. Okay. And don't forget to activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, please click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the checkbox before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, the link for the certificate and the link to the to claim the credit are already given in the checkbox, right? So the access code is hashtag class AYU. Okay, please take note. The link will end half an hour after this live, Make sure to use the EDD email only to log in. Incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. So if you wish to get more information on our online classes, you can go to www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Okay? Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter. I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. So stay safe till we meet again next week, same day and same time. Thank you very much and Assalamualaikum. Bye.
Wow, banyaknya
Thank
hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.